The other thing we need to talk about is that the fibre that is used to construct the fabric, because you've seen, we've looked at very standard illustrations of yarn, but they vary immensely. And in your book we've talked about staple, and in this case we're just looking at I think this might be wool or silk or something, it's a bit hard to tell. But the idea is that the fibres are drawn and they're spun into a particular configuration, and that determines the thickness of the yarn, which is known as count, and it also determines the texture of the yarn. If you take a fibre like wool and you card it, which means you're sort of laying it down and you're running all of the yarns very smoothly and comb it into a very regular format, and then take that and spin that gives you the sort of texture you get in say, a suiting or something like that. Whereas if on the other hand you just do it much more randomly and you spin it as if you're spinning a coarse cotton or something, it actually has a much furrier, rougher feel about it. And so there's a great diversity of yarn types, and there's an even greater diversity of how those yarns are spun into, how those fibres, are spun into yarn. I was trying to get an illustration of, because we deal so much in polyester, trying to get an illustration of how a polyester's created, or a polyester fibre is created, and this is as near as I can find. On this left-hand side, on your left-hand side, there's a head through which the fibre is forced from its molten state, and it comes out a little like spider's web filaments. And those filaments can either be clustered together. You might remember when we looked at the square weave, the first photograph there, there was a pink fabric in the corner there. That was likely to be a cluster of fibres that are held together and woven rather than spun. So these are, you can see the filaments that are sort of held together. Another way of approaching that, in this case, is to pull those filaments that we've seen being extracted through the head, and just literally nipping them together, and they're called twits. So you get these filaments sort of laying down, a bit like very, very fine fishing line, and you sort of hold them together with a little clamp effect, sort of. I don't know whether it's actually slightly melting it or whether it's in fact an adhesive they use.
Two types, and so some people call it crimping.
So this here is actually the polyester beads that are melted and then poured into this hopper, and then it's heated and it's extruded. And the shape of the extrusion, to some extent, determines the luster or the lack of luster of the polyester. And then they'll take these filaments and they'll chomp them up and spin them so that it has more like a woolly look. And so there's lots of effects you can arrive at. A continuous filament polyester fabric usually is fairly highly resistant to pilling and things, because you're not sort of creating loose fibres, which is what causes pilling. That's a topic we can discuss at some other time. But it's quite popular for things like base cloths for draperies and bedspreads, because it has this uncluttered look about it. And here we're looking at how they're bringing the components in and spinning them into a yarn. So they're sort of all fed in, and they're in a rotating sort of action created into a yarn. And then again, the thickness and the texture and so forth can be determined to a very large extent. So, this is a recycled polyester picture, and I wanted to suggest that we can discuss this at some other stage, but there's a very big move towards using fibres that are reconstituted, so that particularly polyester, because it's said to be a non-renewable source in the same way that steel is non-renewable and aluminium and so forth. When you dig it out of the ground, it's eventually going to run out. So there's a move towards recycling or reconstituting. So these Coke bottles are often chomped up into different forms and then re-melted and then re-extruded. This shows you the little beads that are created from what they call post-consumer, which is the bottles, and then in the middle you'll see there's a little bit there that's called post-industrial, and that's taking say, an old fabric and melting it down, which I think is a bit of a rarity, but what they're also using is when you're weaving a fabric like this one we're talking about, it's woven with a very rough edge, and as it comes off the loom, that edge is trimmed off with a pair of scissors, and so they'd reconstitute that, and that's what's called post-industrial. And then you see the filament down the bottom, so that's there for when you want to have a look at that. But that's a whole new topic, and we should really pay attention to that, because that's something that we can't ignore. I think we have a very good record as an industry of treading fairly lightly on the planet, and I kind of get annoyed when I hear, this is a bit harsh, but I hear the tree huggers sort of say that things like cotton are a better solution than polyester, and the truth is far from that. The things like the harvesting of the cotton takes a lot of fuel, the production of cotton takes about 26,000 litres per kilogram of cotton. There's about 15 to 18 or so pesticides and insecticides applied to the stuff before it gets to be useful, and then you've got to decorate it. So from our perspective, we're actually treading very lightly, albeit we are using what they could say is a non-renewable resource. But the other side of that is that the amount of oil that goes into the production of polyester filaments and resins and things is somewhere less than 1% of what we burn. It's not this industry that's the problem, it's the stuff we burn that's the problem. So, anyhow, as I said, it's a whole different topic, and it's a subject we should do. So, that's what I can contribute about weaves.
What would a chenille be based on?
Well, that's a good question.
Say a bedspread.
Yeah.
You know.
The chenille yarns will be one of these kinds of weaves if it's woven. This would be one of the yarns probably in the weft, because it's a bulky yarn, and it's actually created by having a third-dimensional yarn. If you pull the chenille yarn out, it looks a lot like a pipe cleaner. Can you picture a pipe cleaner with a sort of a twisted centre to it and little fluff balls? And that can be created a number of ways. That can be spun fairly conventionally, and then introducing the fibre. It can also be done electrostatically. You can actually glue the chenille fibres onto the central column. There's a raft of ways of doing it, but it's still nonetheless going to be put across a wall. And so and
it could be done as a twill or
a jacquard.
It doesn't matter.
Yeah, that's right. And that's what I'm saying. The diversity of the yarn types is huge. It's a great question. The question that Kim's asked is the recycled PET bottles as durable? Is that what I'm hearing?
Or
it's longevity. Yeah. Well, the answer is no, because the cost of gathering them and cleaning them and getting rid of the cigarette butts out of them and all the things that can go wrong. And then at the outset, and it's a very interesting and good observation, Kim, the resultant 100% recycled PET doesn't give you the same strength and abrasion resistance as other recycled. And that's actually why they've come to the point where they're using this 80% post-industrial, taking the clippings off the side and any crook fabric that perhaps has got flaws in it. Instead of selling it, they'll melt it down and reconstitute it. So it's typically the stuff that's coming through from all of the things we're doing is a mixture of 80% post-industrial, which is what I've just described, and 20% of the PET. It takes about 16 bottles, I understand, to make a square metre of fabric. And you can sort of imagine what's involved in getting 16 bottles in one. I've been trying to get accreditation for our activity. We're trying to get all of these green things, and everybody's got a green something. There's a green frog and a green leaf and a green fern and a green tree and a green tick. It goes on and on and on, and none of them have got any substance to them. Really. I rang a friend in the States the other week because he had a green palm certification. I said, "That's fantastic. Yeah, it's going gangbusters." And I said, "Well, can we sort of fall into that compliance thing?" He says, "Oh, sure." I said, "Who is it?" He says, "It's us." We've set the standards and we comply with them superbly. So it's a tough one, and I don't, as much as I'm making light of it, it's something we really have to finally grapple with, because it's not going to go away. But I tell you, it's an amateur game at the minute.